lab conservation of momentum. This is a very simple lab that we measure the position versus time of the collision of two cars, but only one car was initially moving, the other one was at rest. The two cars comes together, and because I put a velcro between the two cars, they attach and move together. So the measurements are the mass of the first car, the mass of the second car, the initial velocity of the first car that I pushed, the second car is at rest, and then the two cars are together, so I don't need labels 1 or 2 for them because they are together, is one entity. So first let's calculate the momentum of the first car. So you press the equal sign, and it's mass times the initial velocity of the first car. And this is the momentum of the first car. Because the second car was at rest, the momentum is 0 for the second car. And because the total momentum is the sum of the momentum, is this plus 0, that is going to be this. It's going to be the initial momentum is the momentum of the first car because the second wasn't moving. Now for the final momentum, they are together, so you need to add the masses m1 plus m2 times the velocity of the cars together that I call Bf. And as you can see, these numbers are close to the initial momentum of the system, equal to the final momentum of the system. And now we have a couple of options over here. The first thing that we could do is to how you compare the two quantities are equal. How do you compare that two quantities are equal? You could minus them, and then it's supposed to be 0. And then if the average is close to 0, you say yes, the quantities are equal. Let's do that. So let's do PF minus P initial. Let's put another color over here. So you press the equal sign and you do this minus this. And if it's not a systematic error, some quantities are going to be, some differences are going to be positive and some are going to be negative. So the average is supposed to be close to 0, and is indeed negative 0.03. So that's the first indication that the two quantities are equal. Sometimes it's positive, sometimes it's negative, but look how close is the average to 0. The second option is to do the graph. You put final momentum in the vertical axis, and then you put initial momentum in the horizontal axis, and you're supposed to have a linear regression with y-intercept 0 and a slope 1, and that's what we are going to do now. So you click a blank cell away from the data so Sheets doesn't try to interpret what you are going to graph. So you press the chart, and now it's scattered, and the data range is the horizontal axis first, that is the I column, if you see over here. I mean the H column first, so you go from H2 semicolon, and because I'm going to keep adding the data for all the classes today, this is just the first class, I will put H 100. I'm not going to get 99 points, but in case I do, everything is there for that. And then I will do PF is I column, so I2, I100. And this is the data. Then you go to customize, put what the horizontal axis is P initial in kilograms times meters per second. If you want to put total, but I don't want to. And in the vertical axis is P final of the system, the total kilograms times meters per second. Alright, and then close this menu and go to series. Let's put I like the points to be black and 4 because it's going to have many points. You put the trend line and then label use equation, and I'm not going to put r square. As you can see, the slope is 1.1 and the y-intercept is negative 0.1. So this is a good indication that the momentum of the system is a conserved quantity. After the collision, it has the same value before the collision. Okay, if you double click over here the equation, you can edit it and you could put what this is. This is PF equals 1.09 P initial. And I think this is now complete. Because I'm going to be adding more data, I will put the average over here. So we put the average over here and press the equal sign, average 8 to 12. No, I don't want to fill, I just want the first. No, that's not what I want. Average, and then select the numbers you are calculating the average, and I will delete this from here. So as you can see, there is I'm showing you two ways to experimentally observe that two quantities are equal. One way, you find the difference, and the difference is supposed to be close to 0. Hopefully, if there is not a systematic error, some differences are positive and some differences are negative. If you see all the difference positive or all the difference negative, there is a bias in your experiment. That means that you have a systematic error in your experiment. The other way is to do a graph, one quantity in one axis, the other quantity in the other axis, and if the two quantities are equal, the slope is supposed to be 0. The y-intercept is supposed to be 0, and the slope is supposed to be 1. And that's what you see over here. You clearly see that the slope is 1.09 and the y-intercept is 0.09. Do the grids just for fun. Alright. In the previous videos you saw how the measurements were obtained.